So we're going to be going over a review of macromolecules. We're going to look at what the four types are, what they're made of, how they're composed, and why, some examples of them, and why do we care about them? What do we need macromolecules for? So if we remember back, the four macromolecules that we have are carbohydrates, lipids, proteins, and finally, nucleic acids. So we're going to break each one of these down and talk about them, but it's important to know what we're actually talking about first. So the way that I like to think about macromolecules is they are just like Legos, the monomers. Mono meaning one single unit, and when you put these Legos together, stack them all up, you make your house or your car or whatever you're putting together. So you take each one of these Legos, these building blocks, and you put them, a whole bunch of them together, stack them together, add them, and that's when you come up with your poly meaning many, polymer. So polymers, when you get a whole long chain of polymers strung together, that's what actually ends up making your macromolecules. So let's start off with carbohydrates. We're going to come to find that all the macromolecules have a few things in common. Most basically, carbon, hydrogen, and oxygen. All of the macromolecules are composed of carbon, hydrogen, and oxygen. Now it's important to remember that if we go back to this drawing that we have right here, this glucose molecule that I had on the first slide as well, these points right here, here, there, and there, everywhere that the lines bend, at that corner there is a carbon molecule. Now we said that the carbon, hydrogen, and oxygen are what actually make it up, and you can see there is no other element besides carbons, oxygens, and hydrogens in this molecule. And this is what the monomer is. The Lego building block of carbohydrates is partially this structure along with some others, and they are called monosaccharides. And as I was saying, the monosaccharides, this monomer, when you put a whole bunch of them together, if you start out with one and add another one to it, then it becomes a disaccharide. As you keep adding and adding and adding, that's what makes up the complex carbohydrates. So that diagram on the previous slide is an example of a carbohydrate. It was glucose. Anytime you hear a word, most times that you hear a word that ends in O-S-E, it is a sugar, which is a carbohydrate, which is carbohydrates. So along with glucose, we have fructose, galactose, sucrose. And there's more. There's maltose and mannose. But just because a word ends in OSE, that is not the only requirement to be a carbohydrate. We also have glycogen, and another very common one I'm sure you've heard of is starch. So why do we actually care about carbohydrates? What is their importance, significance to us? Well, carbohydrates, sugars, are a great way to get energy. Think about when you have that soda, you have a feeling of energy. That's because my poison's Mountain Dew. But that's what the sugar in it, we break it down. That's what provides you with energy. We also use carbohydrates for structure. And the final way is for food storage. In plants, that's the starch, and in humans, we store carbohydrates as glycogen. So now let's look at lipids. Lipids is another macromolecule that just contains carbon, hydrogen, and oxygen. But it is actually made up of two separate parts. A long chain fatty acid and glycerol. Now let's take a look at some examples of lipids. We have triglycerides, which are fats. Then we also have oils, waxes, and steroids. Now, why do we care about lipids? Well, because of that really long carbon chain, that makes lipids a very good source for energy. Along with that, we use it structurally. It's earwax, the fat that protects the inside of your organs, inside your body. We also use lipids to absorb vitamins, fat-soluble vitamins. Another importance is the storage of your food. Last, we use it as insulation. Keeps us warm. Bears, when they hibernate, eat a lot of food, get heavy, so that they can stay warm over the whole winter. Now let's move on to the proteins. Proteins contain the normal three, carbon, hydrogen, and oxygen, but they also contain a fourth element, nitrogen. And proteins, they're made up of what we call amino acids. There's 20 of them that exist. Our body makes 12. which means there's 8 left over that we need to ingest. Some examples of proteins are enzymes, hormones, collagen and keratin, as well as hemoglobin. And what's so important about proteins? Well, when I think about protein, first thing that comes to my mind, meat, steak. That is what protein is. We use it structurally, our hair, our fingernails, our skin, it's all protein. We use it enzymes. What do enzymes do? They regulate chemical reactions. We also use it for defense. That's what the antibodies do. And we also use it for transport. That's the hemoglobin. And last but not least, nucleic acids. What makes up nucleic acids? Well, the Lego piece, or monomer, of nucleic acids. Nucleotides. Now these contain all of the elements that we talked about before. Carbon, hydrogen, oxygen, nitrogen, but they also contain one in addition, phosphorus. Now if we want to look at examples, simple. DNA and RNA. And that makes the importance pretty basic. Hereditary information. Now what do we mean by that? Well, that's what makes you who you are. Let's say you have red hair, blue eyes. You get that material from the DNA and RNA. It's passed along from your parents. And that in turn creates the proteins that make up who you are. So to wrap this up, basically what we talked about today are macromolecules. All 4 of them. Carbohydrates, proteins, nucleic acids, and lipids. Also talked about their Lego pieces, as I like to call it. Their monomers. What makes them up? Gave examples for each one. We also talked about why they're important, why we care about them, and what they lead to.
Made with Doodlecast Pro.